Hello class, this is one more example on graphing trigonometric functions in terms of the period of the function. In this example, we'll be looking at tan. So I've drawn here, using a graphing calculator, the regular tan of x. Right, but we're going to be graphing tan of 2x and tan half of x. So let's get straight to it. First, we should always find the period, which is, for tan, is always going to be pi divided by the coefficient here, so divided by 2. That means that is pi on 2. So this one cycle, so remember, this cycle here is normally pi, it stops here. That cycle repeats, like so. But that cycle is between 0 and pi, but it's going to be squeezed in from 0 to pi on 2. So it'll look something like, so from 0 to pi on 2, it'll look something like this. But let's be a little bit more accurate and find the critical points. The first critical point we should consider is the asymptote. Let's draw it in green here. So it's originally at pi on 2. So the original asymptote is pi on 2. And we're going to divide this by the coefficient here. So pi on 2 divided by 2 becomes pi on 4. So the asymptote, which was originally pi on 2, is now going to be at pi on 4. The next critical point we should find is this point here, 1. So it's originally at pi on 4, and we're going to halve that, which becomes pi on 8. Pi on 8 is halfway between 0 and pi on 4. So halfway looks approximately here. So that is our 1 value. And much like this curve that goes off to infinity along the asymptote, we're going to do the same. This off to infinity. Our next critical point here is -1. That -1 is at 3 pi on 4. We're going to divide this by the coefficient of x there. So 3 pi on 4 divided by 2 is 3 pi on 8. You can check this, but it's going to be halfway between pi on 4 and pi on 2. So this point here is -1. Our next critical point here is pi. Okay, so pi is at 0, so normally it's here, but because we're going to halve every point its distance, pi divided by 2 becomes pi on 2. So this 0, which is originally here, is now moved to here. Finding our next critical point, this 1 here, it's at 5 pi on 4. It's now going to be moved at, so 5 pi on 4, we're always going to divide by that coefficient, which becomes 5 pi on 8, which you can check it yourself. It's going to be halfway between these two values here. So that point there is going to be our 1 value. So now, because this kind of matches that curve, it goes off to infinity, we should try and match the look of that. Before we continue, we should figure out where this asymptote is. It's the same, it is the same procedure. This asymptote is originally at 3 pi on 2. But we're going to halve its distance from the y-axis, which becomes 3 pi on 4. So this asymptote is going to be at 3 pi on 4, like this. So this goes off to infinity. And I hope you can see the pattern now that we have, well, one cycle was actually from here. But now that we have this going for us, we can continue this pattern. We can see that between pi and 3 pi and 4, that's kind of 2 spaces apart. So 2 spaces apart, we can draw another asymptote. 2 spaces apart again, that's another asymptote. And then it goes off here. Now we can find the zeros by repeating this pattern. We can find our 1 values. And the curves as they go off to positive and negative infinity. There we go. Sorry, let's finish this off. We're stopping at 2 pi because originally the question asked us only to graph from 0 to 2 pi. Let's do one final example. Let's move this down. Let's eliminate all our lines. So let's first find our period. The period for tan is always going to be pi, and we're going to divide this by half, the coefficient of x here. Pi divided by half is 2 pi. So this one cycle here of going up to infinity, asymptotes, and then to 0, this is going to be stretched out all along this function here. Okay, so we're going to figure out where the asymptote is first, the 1s and the 0 values. Here we go. So it begins on 0. Let's first find this asymptote here. So pi on 2, we're going to divide this by half. This is the same as pi on 2 times 2 on 1, which is just pi on 1, which is pi. So this asymptote, which is originally here, is now going to be moved to pi. So our asymptote is going to be here. Let's make it green. Let's find this 1 value. This 1 value is originally at pi on 4. We're going to divide this by half, which is the same as pi on 4 times 2 on 1, which is pi on 2. So this 1 value, which is originally here, is now going to be here. Now the rest of the value is hard to determine what it is, so we're just going to do it like this and let it go off to infinity like so. Let's now find this negative 1 value. It's originally at 3 pi on 4. And as you've seen, we're dividing by half, which is the same as multiplying by 2 on 1, which is 3 pi on 2. So this negative 1 value, which is originally at 3 pi on 2, is, at 3 pi on 4 here, is now going to be at 3 pi on 2. And because the function ends on 2 pi, it has to end back there. So we can kind of graph this like so. And there's our graph, tan half x. So I hope I gave you an insight into finding all the critical points, the asymptotes, and how it changes according to the coefficient of x. So I hope that gave you an insight into the period of graphing trigonometric functions. Hope to see you in the next video. Best of luck.